So I used to just be a voice. And then on election night, I showed my face because everybody was so cozy and chatting. So on Einstein's third try at a great unifying theory, he failed, mainly because he lacked the symmetry that would unite gravity and light. He, of course, was acutely aware that he lacked a fundamental principle that would guide him through the thicket of tensor calculus. He once wrote, "I believe that in order to make real progress, one must again ferret out some general principle from nature." But that is precisely what the superstring provides. The symmetry underlying the superstring is called supersymmetry. So it's called supersymmetry or SUSY, a strange and beautiful symmetry that unifies matter with forces. As mentioned earlier, subatomic particles have a property called spin, acting as if they were spinning tops. The electron, proton, neutron, and quarks that make up the matter in the universes all have spin 1/2, and they're called fermions, named after Enrico Fermi, who explored the properties of particles with half-integral spin. The quanta of forces, however, are based on electromagnetism with spin 1 and gravitation with spin 2. Notice that they have integral spin and are called bosons. So I mentioned in the particle family called bosons, and those things have integral spin. Oh wow, happy birthday. The key point is that in general, matter is made of fermions with half-integral spin, while forces are made of bosons with integral spin. Supersymmetry unifies fermions and bosons. This is the essential point that supersymmetry allows for unification, which Einstein wished for. In fact, supersymmetry allows for a new type of geometry that has even surprised the mathematicians, called superspace, which makes possible supermarble. In this new approach, we must generalize the old dimensions of space and time to include new fermionic dimensions, which then allows us to create a superforce out of which I got a text. Out of which all forces originated at the instant of creation. 1 second. Let me put this on Do Not Disturb. What does spin 1/2 mean? So we can, it's a property of quantum particles. It's a property of quantum particles. And when we discuss quantum mechanics, we can go over it. But it's sort of like, you know how charge is a property of particles? Spin is also a property of particles in quantum mechanics. Okay? Some physicists have speculated that one must generalize Einstein's original principle of general covariance to read, the equations of physics must be supercovariant, that is, maintain the same form after a supercovariant transformation. So you already saw my live and came back? Now, you need to watch the whole thing. You need to watch the whole thing. I don't have to suffer. Her cackle is fine. What do you have against her laugh? Superstring theory allows us to reanalyze Einstein's old work on the unified field theory, but in an entirely new light. When we begin to analyze the solutions to the superstring equations, we encounter many of the bizarre spaces that Einstein pioneered back in the 1920s and 1930s. As we saw earlier, he was working with generalizations of Riemannian space, which today can correspond to some spaces found in string theory. Einstein was looking at these bizarre spaces one after the other in agonizing fashion, including complex spaces, spaces with torsion, but he got lost because he lacked any guiding